Welcome students. Now we are going to start with our new topic, that is the metal cutting or machining. Okay, so very important topic. A lot of weightage you can find in the examination. So let us start with this new topic. Okay, so what is mean by metal cutting? So metal cutting is nothing but the analysis of the material removal, or in simple fashion we can call it as it is a process in which the excess material from the workpiece is going to removed, and you are going to get the required shape and size of the component. So here whatever the excess material, you are going to cut it by using the tools, and the study of material removal is nothing but the metal cutting. Okay, now before going into the details, if we talk about what is the need of learning this topic. Okay, so as I said that this is the analysis of material removal. So by doing this analysis, what are the things that we are going to determine before we are actually doing the operation? Okay, so here the things that we are going to understand or going to get by studying this particular topic are, of course I am talking about the analysis of metal cutting. So what we are going to get? So first thing that we are going to get is that the forces which are going to induced during the machining process or in the machining zone. Okay, so we are going to understand about the forces. So if you are knowing the cutting forces in the operation, then how these forces are going to help us? So definitely by using these forces we can able to have the correct or required rigidity of the machine tool, isn't it? So once you are getting these cutting forces in the operation, so we can able to define the rigidity of machine tool, isn't it? So first thing is what? By the knowing of the forces, we are going to get rigidity of machine tool, isn't it? So first thing is that by knowing the forces we can get the rigidity of machine tool. So on that basis we can able to have required rigidity, which basis cutting forces are there. The second thing that we are going to understand or going to know is that the power consumption. So if you are knowing whatever the power that is going to consume during the operation in that machining process, so based on that we can able to select the rating of the prime movers required for that machine tool. So once you know the power consumption, so we can able to have the rating of the machine tool, not the machine tool, the rating of the prime movers. These are nothing but what? The motors, isn't it? So you can able to understand what will be the horsepower of the drives that we are going to use into the machine tool. Third thing is that the temperature induced in the cutting zone temperature. So if you know the cutting zone temperature, metal cutting zone temperature that is going to induce during the process, so based on that temperature you can have the certain mechanical properties of the tool. Say for example, for the tool material, the important property is so called as the hot hardness. So this is nothing but the hardness of the tool material at the maximum or at the highest temperature. Okay, or simply you can define like that: the ability of the tool material to withstand with the high temperatures without losing its strength and hardness. कहाँ पे? at higher temperatures, at higher temperatures. So this is very important property for the tool material, and you are able to understand what are the temperatures are going to induce in the cutting. Then definitely based on that you can able to select which material, which tool material can withstand that temperature. Based upon the hot hardness value, you can easily select the proper tool material for that machining process. So from the temperature you can able to understand about the hot hardness of the tool material. Based on that you can select the selection of tool material. And the fourth thing that I am going to discuss, that is the tool life. That is the tool life. So how is the tool life of the given tool? So based on that, if you want to increase or enhance the tool life by, of course, some process parameters which is used in the metal cutting, that is speed, feed and depth of cut. So to have the maximum value of the tool life, you are going to select the appropriate machining parameters in that process, machining process, so that the tool life will be maximum. Okay, so based on that, what you can able to do, the selection of proper or optimum the machining parameters, machining process parameters like speed, feed and depth of cut. So see, when you are analyzing this machining process, definitely in advance you can able to understand some of these important points or parameters, so that you can have the optimum values for all these. You can have in advance about the rigidity of the tool, about the cutting tool materials, about the tool life, etc. Okay, so in this way the study is helping us. So this is the So this is the importance of studying this topic, metal cutting. The next thing that we are going to see, the different types of cutting tools. Different types of cutting tools. So there are two basic cutting tool types. One is single point cutting tool, and the second one is multi point cutting tool. Okay, so single point cutting tool and multi point cutting tools. Now what is mean by this single point cutting tool? Okay, so single point cutting tool is what if only one cutting edge of the tool is removing the material or participating in the cutting operation, then it is known as the single point cutting tool. Example, we are having on lathe the turning tool, single point cutting tool. Then on shaping we are having the single point cutting tool, or in the planning, which the tool we are using is the single point cutting tool, isn't it? Now what is mean by multi point cutting tool? If more than one cutting edge is participating into the material removal or removing the material of the tool, is removing the material or participating into the cutting, then it is known as multi-point cutting tool. For example, we are having milling cutter is there, drill bit is there, okay. Then we are having grinding wheel is there, okay. So these are multi-point cutting tools, okay. So only one cutting edge is removing the material or participating into the cutting, single point cutting tool. More than one cutting edge, it is multi-point cutting tool, okay. Now let us see which are the factors affecting the machining operation, okay. Next point, what we are going to see, the factors affecting the metal cutting or machining. So the first thing, what? The workpiece material, the workpiece, okay. Of course, when the workpiece is soft, you require the lesser hardness tool material, and the workpiece is hard, you require the higher hardness workpiece material, okay. Again, for machining of the say ductile material, we require the less cutting forces, and for the hard material, say we are going to have the higher cutting forces. Like that, the workpiece is one of the important parameter which is going to affect the metal cutting operation, okay. So how your workpiece is, it is soft or it is hard, based on that you are going to select the appropriate tool material, like that. The second important thing is that interaction between tool and workpiece. What is this? So interaction between tool and workpiece is nothing but the selection of process parameters, that is speed, feed and depth of cut, If you select the optimum values for this, your machining is going to be a good machining, isn't it? So interaction between tool and workpiece is nothing but what? The proper selection of the parameters, machining parameters like speed, feed and depth of cut, okay. And the third thing is important, that your tool geometry. So what is tool geometry? So tool geometry is basically refers to the tool angles, then the shape of the face and the form of the cutting edges. What is tool geometry? So tool geometry refers to the tool angles, shape of tool face and the form of cutting edges, okay. So very important, इसके बाद हम बात जो करेंगे, definitely we will talk about this tool geometry, okay. And you know what is in the tool geometry? So it is referring to the tool angles, the form of the tool faces and the shape of the cutting faces and form of the cutting edges. So now we are going to talk about the tool geometry. And in this tool geometry, we are going to learn first the single point cutting tool and then multi-point cutting tools. So for single point cutting tool, I am going to draw the diagram here, okay, so that we can define the terms and definitions, involved in single point cutting tool, okay. So let us see how to draw this single point cutting tool. Is isometric view I am going to draw here. So see here, draw a cube first. So this is our single point cutting tool. I hope it is looking like a single point cutting tool. And this is the shank of the tool. So see, this is the single point cutting tool. I have drawn the isometric view of this tool. Okay, and various terms that we are going to use, that I am going to write it here now. This is the end flank. This is the shank. This is the base. This is the major cutting edge. Major cutting edge or major cutting edge or principal cutting edge, and this is the minor cutting edge or auxiliary cutting edge. Okay, this minor cutting edge or end cutting edge. This is the side cutting edge. This is also known as the side cutting edge. Many names are there, please remember it is a major cutting edge or side cutting edge. This is end cutting edge or minor cutting edge. End cutting edge. Okay, so this is the major flank and this is the end flank or minor flank. Minor flank. This is what? The tool axis. This is the tool axis. Okay, and this is the nose. This is the nose of the tool. So see, these are the basic things, and this is what? Our cutting part of the tool. Okay, and you can see here, this is the tool face. This is what? The tool face. Okay, so this is the single point cutting tool that we are going to see first. And what are the terms here? So number one, the face. So what is face? So face is the portion or the surface which will give the convenient direction to the chip flow. So face, it will give the convenient direction to chip flow. Okay, so this is the face. Then what is the nose? Or first of all, see what is the cutting edge. So the cutting edge which will participate, the edge which will participate in cutting. So this is the cutting edge. कौन सी cutting edge है? This is the major cutting edge and this is the minor cutting edge. Okay, or this is the side cutting edge and this is end cutting edge. Okay. Third thing is a nose. So nose is what? This is the arc or chamfer, or this is a junction of the side cutting edge and end cutting edge. This is the junction of, यहाँ पे दो कटिंग एज मिलती है, कहाँ पे? ये नोज पे. दिस इज द नोज. एक मेजर कटिंग एज, एक माइनर कटिंग एज. ओके, this is, say I will write here side cutting edge and end cutting edge. So this is a junction of the two cutting edges, side and end. And the fourth, we are having the flank. What is mean by flank? The surface below the cutting edges, the surface below the cutting edges is known as the flank. See, this is end flank, this is the major flank. So below the cutting edges, whatever the surface you are having, this is the flank. Okay, so these are the terms that we are going to use in the single point cutting tool. Okay, now of course in tool geometry we are going to define what I said, the tool angles. And see, these tool angles are very important because they are directly influencing the performance of the tool, isn't it? And that is why the selection or the choosing of these values for the tool angles is very important thing. Okay, so that is with intense care we have to select the values of various tool angles in the tool geometry. So let us see that. So the thing is that we are going to understand about now the various angles, how these angles are represented onto the single point cutting tool. Okay, so that we will continue. Thank you.